I throw an unbiased die 6 times. I calculate the probabilities that the 6 scores obtained will consist of exactly 2 sixes and 4 odd numbers. 4 odd numbers. Okay, so first of all, you think about it is something like I'm throwing something 6 times. So there could be a lot of possibilities, right? It could be I could have 2 6 followed by 4 odd, or can 1 6 1 odd. Okay, so there are a lot of ways. So here, if you think about the number of ways, so first of all, if I want to obtain 2 6s, 2 6 maybe, then one time it's 1/6. Second time also 1/6, right? So this is probably getting 1/6 twice. Okay, then after that I want to get odd number. Odd number can be 1, 3 or 5, right? So it's like 3/6, right? So getting 4 odd numbers, that means it's like 4 odd numbers, right? So power 4, right? But the number of ways in which this can happen, it could be that I'm getting, because I'm throwing 6 times, right? It could be that, I could be getting things like 6 and 6 and then followed by odd, 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 odd. Could be 6 odd, 6 odd, 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 right? So there's so many ways. So how many ways can I get 2 6s and 4 odds, right? So the number of ways could be, you think about it, right? It's just like, it looks like an arrangement problem. It's actually arranging 6 items where 2 are the same, the 2 6s and the 4 odd numbers, right? So this will just be equals to, so this will be a total number of ways I can obtain 2 6s and 4 odd numbers. Alright, multiplied with this, right? So obtaining 1/6, right? 2 6s, 4 odd numbers multiplied by the total number of ways which I can obtain the numbers, just give me 5/192. Right, so this will be one way to look at part 1. Okay, another way to look at part 1 is I can also say that if I were to look at the first one, now the first time I throw, number of ways to obtain. Each time if I want to obtain 6, right, there's only one way, so it's like one way. Second time obtain also one way, right? So it's like 1 power 2. The number of ways you can obtain an odd number is 3 ways, right? I'm going to throw it 4 times, so it's like 3 power 4, right? Over the total number of ways, which I'm talking about arrangement, 6 factorial over 2 factorial, 4 factorial, right? This is the number of ways I can obtain 2 6s and 4 odd numbers, right? In a row arrangement, means I'm throwing the order matters. And finally, the total number of ways to arrange 6 numbers repetition. This will just be 6 power 6, right? Because each time I throw, I have 6 possibilities, right? Second time I throw, I have 6 possibilities, so it's 6 power 6, right? So this would just be equals to again 5/192, right? So this is just the number of ways to get 2 6 and 4 odd in row arrangement over the number of ways to arrange 6 numbers that has repetition. So this is answer for part 1, right? Part 2, it has to be 1 2 3 4 5 6 in some order. So meaning how many ways can we choose 1, then we choose 2. So it has to be 1 3, but it can be 1 3 2 5 4 6 in some order, so it may not be so the 6 scores obtained will contain 1, will contain 2, contain 3 4 5 6. So in each possibility, the number of ways we choose 1, as is like 1/6. Number of ways we choose 2, also 1/6. Right? So each time, because it's so specific, each time if you want to choose a particular number, it's only 1/6, right? Like again, the number of ways which can choose 1 2 3 4 5 6, there are so many ways we can choose, right? So again, we also can choose 2 1 4 5 3 6. So how many ways in total? There are a total of 6 factorial ways. So we multiply by 6 factorial ways, right? Because there are 6 factorial ways in which I can choose the 6 numbers separately. And this will give me 5/324, right? And part 3, it has a product which is an even number, right? Product which is an even number, right? So if I want a product which is an even number, as long as right, the key thing is for me to have a product, these 6 scores, right, will have a product which is even number. Then as long as one of the numbers, right, is odd, is even, right, no matter if it's odd or also can be, example, if I give you maybe 1 times 3 times 5 times 7 times 9, all these 5 numbers, if all I need to do is multiply at least, right, one even number, right, and this will be an even number because you can see it's a multiple of 2. So the key thing is this: for me to have an even number, I just need at least one of them to be even. So we think about the complement. This is the same as 1 minus the probability that all digits are odd. The only way for me not to have an even number is that all of them are odd. Okay, so how am I going to get all these? So it's just simple: 1 minus number of ways I'm going to get all odd numbers is just 1 over 2 power 6, right? And the answer will just be 63 over 64. Okay, and part 4, it'll be such that a 6 occurs only on the last row, and exactly 3 of the first 5 rows result in odd numbers. So 1, 2, 3, 4, 5, 6. This one has to be the number 6. Alright, how many ways can this happen? There's only one way. It has to be a 6. And over here, there are 3 of the first 5 rows that result in odd numbers. So out of the 3 first 5 rows, is we are looking at maybe odd numbers happening 3 times. Okay, so even numbers, because it cannot be 6, right? It can only be 2 and 4. So the number of ways to get is like 2, probably 2 out of 5, or 1 out of 3. Okay, 1 out of 3. Okay, because it's 2 and 4, and over 6 is 1 out of 3. Right? How many ways can this happen? Right, so it can be 5 factorial over 2 factorial, 3 factorial, right? And yep. And finally, for the last one, we need it to be the number 6. So it's just multiplied by 1 over 6. It can only happen one way with 1 over 6. Right? So answer will be 5 over 216.